secondary service conductors from the utility pad mount transformer to the service disconnect switchboard must be installed in metal conduit. The secondary service conductors from the utility pad mount transformer to the service disconnect switchboard cannot be installed in PVC conduit. The fine print note in the 2002 National Electrical Code Handbook 517.30C3 does not mean that the emergency system circuits must include services, feeders, and branch circuits. It simply means that they can include these elements. However, the secondary service conductors are not part of the emergency system. They are part of the normal electrical distribution system. Therefore, they are not covered by the requirements of the fine print note in 517.30C3. The general rule for installing service conductors is that they must be installed in metal conduit, as detailed in National Electrical Code Section 230.43. This is because the service conductors are exposed to the elements and need to be protected from physical damage and the environment. Let's break down the rationale behind this requirement and examine the relevant sections of the National Electrical Code. Firstly, it's crucial to understand the definition of service conductors. Service conductors are the wires that run from the utilities transformer to the service disconnect, which is typically located inside or just outside the building. These conductors carry the entire electrical load for the building, making them a critical part of the electrical system. Because of their importance, the National Electrical Code places stringent requirements on their installation to ensure safety and reliability. Secondly, the primary reason for requiring metal conduit for service conductors is physical protection. Service conductors are often located outdoors, either underground or overhead, where they are exposed to a variety of hazards. These hazards can include mechanical damage from vehicles or equipment, damage from rodents or other animals, and damage from weather events such as storms or floods. Metal conduit provides a robust barrier against these hazards, protecting the conductors from damage that could lead to electrical faults, power outages, or even fires. The National Electrical Code provides specific requirements for the type of metal conduit that must be used for service conductors. These requirements are typically found in Article 344 for rigid metal conduit, Article 348 for electrical metallic tubing, and Article 356 for liquid-type flexible metal conduit. The specific type of conduit required will depend on the specific installation conditions, such as whether the conduit is buried underground, exposed to the weather, or subject to physical damage. In addition to providing physical protection, metal conduit also provides a grounding path for the electrical system. When properly installed, metal conduit is electrically continuous, meaning that it provides a low impedance path for fault current to flow back to the source. This is important because it allows overcurrent protection devices, such as circuit breakers and fuses, to quickly trip and energize the circuit in the event of a fault. This helps to prevent electrical shock and reduce the risk of fire. The National Electrical Code requires that metal conduit be properly grounded to ensure that it provides an effective grounding path. The specific grounding requirements are typically found in Article 250 of the National Electrical Code. These requirements include the use of grounding bushings, bonding jumpers, and other grounding hardware to ensure that the conduit is properly connected to the building's grounding system. Another important consideration when installing service conductors in metal conduit is the full capacity of the conduit. The National Electrical Code limits the number of conductors that can be installed in a given size of conduit. This is to prevent overheating of the conductors, which can lead to insulation damage and electrical faults. The full capacity of a conduit depends on the size of the conduit, the size of the conductors, and the type of insulation on the conductors. The National Electrical Code provides tables in Chapter 9 that specify the maximum number of conductors that can be installed in a given size of conduit. It is important to consult these tables before installing service conductors to ensure that the conduit is not overfilled. In addition to the general requirements for service conductors, the National Electrical Code also has specific requirements for service conductors in healthcare facilities. These requirements are found in Article 517 of the National Electrical Code. Article 517 addresses the unique electrical needs of healthcare facilities such as hospitals, nursing homes, and clinics. These facilities require a higher level of electrical safety and reliability in other types of buildings because of the critical nature of the services they provide. The fine print note in the 2002 National Electrical Code Handbook 517.30C3 addresses the requirements for the essential electrical system in healthcare facilities. The essential electrical system is a backup power system that provides power to critical loads in the event of a power outage. These loads can include life support equipment, operating rooms, and emergency lighting. The fine print note in 517.30C3 clarifies that the essential electrical system can include services, feeders, and branch circuits. This means that the essential electrical system can be supplied by the same service conductors that supply the normal electrical system. However, the fine print note does not change the requirement that service conductors must be installed in metal conduit. The service conductors that supply the essential electrical system must still be installed in metal conduit, even if they also supply other loads. It's important to differentiate between service conductors and other types of conductors, such as feeders and branch circuits. Feeders are the conductors that run from the service disconnect to a distribution panel. Branch circuits are the conductors that run from the distribution panel to individual loads, such as lights and receptacles. The National Electrical Code has different requirements for feeders and branch circuits than it does for service conductors. In some cases, feeders and branch circuits can be installed in PVC conduit depending on the specific installation conditions. However, service conductors must always be installed in metal conduit, regardless of the installation conditions. PVC conduit is a type of plastic conduit that is commonly used for electrical installations. PVC conduit is lightweight, inexpensive, and easy to install. However, it is not as strong or durable as metal conduit. PVC conduit is also not electrically conductive, so it cannot be used as a grounding path. For these reasons, PVC conduit is not permitted for use with service conductors. In summary, the secondary service conductors from the utility power mount transformer to the service disconnect switchboard must be installed in metal conduit. This is because the service conductors are exposed to the elements and need to be protected from physical damage on the environment. The National Electrical Code requires that service conductors be installed in metal conduit to ensure electrical safety and reliability.